Hi there. Welcome to the third video of FlexSim tutorial. Previously we covered uh, a lot of things. We're going to start right from where we left off. From here, the port and port connectors, you can see the objects in the simulation model need to be connected in some way in order to interact during a simulation model. So one of the ways in this object can be connected is through port. So in the simulation model, so you can see these are the ports, okay? This block and this block. So this block is the output port and this block is the task executional port. So we have already covered the input and output port, but let's see what it says. So this port determine how and when a flow item passes from one fixed resource to another. So when an output port on one fixed resource is connected to the input port of another object downstream, the flow item will pass through from the first object's output port to the next object's input port. So you already know that. So let's see if I were to explain that. So this is my output port of the source block, which is a fixed object, and this is my input port of the QE fixed object. So, and this is the output port of QE1 block object. So the green one is the input and the red one is the output. Okay, fine. Okay, so the center port. When a center port of two objects are connected, it creates a reference point between those two objects. Center ports allow objects to communicate or interact. Center ports are most typically connected a fixed resource to a task executor. So in the software, this one is called the uh, input port and output port. Okay, and this one, the rectangle, is called the center port, which is connecting a fixed resource to a task executor. So hopefully you have understood. Okay, so here is a note. So it's saying that it is also possible to connect objects in FlexSim using a tool called list, or we could possibly control the connections between our object by using the process flow tool to build custom model logic. So yeah, that's also possible. So using the process flow, we can actually connect the task executor with the fixed block. So we're coming to that in time. Okay. So in the next thing is main menu, toolbar, simulation control bar. So as in most software program, the main menu contains all of the tools and commands we might use while building the simulation model. So it's referring to this block. Okay. So this is my uh, main menu. So this is my main menu. So it has got everything that I need to build the model. So the toolbar gives quick access to many of the commonly used tools and commands in FlexSim. The simulation control bar, also called the control bar for short, contains the tools and commands we will need to run our simulation. So this is referring to this one, which allows us to run the simulation, to stop the simulation, to speed up the simulation, to start it from the beginning. Okay. So if you see, when I click on the run, the model starts to work. And if I click on the first forward, it goes way too fast. Okay. So if I stop it there, I can see uh, if I click on the reset, it will start from the beginning. Okay. So the next thing, the environment, the located in the top right corner, the environment button. So let's see where is that. So top right corner. It says it's on the top right corner. Tools, script background. Okay, I don't see it. Okay, fine. Let's see. This option. Okay, this one. This icon. Let's look for that icon. Square. Mm, oh, right here on the top right. This is the environment. Okay. So environments customize the look and feel of the program. So let's say healthcare. Okay. Let's see. Okay. So it changed. So this switched to the healthcare version of FlexSim. So if I change it again, exit environment. So it just brought me back to the FlexSim. So it just switches to the environment of the FlexSim. So there are some differences. So this is more about a hospital. As I can see the location, the staff, everything is related to a doctor and the medical service. Okay. So for now, we are going to be on the default environment. Okay. So with that, we have covered the overview of the FlexSim user interface. So we are going to go back to the tutorials. So there is some basic tutorial now. Let's say FlexSim basic tutorial overview. Okay, so here we can see this is a basic tutorial. So this tutorial is designed to teach us the basics of building a simulation model in FlexSim. So we will create a simulation of a customer service center with the goal of making the service center run more efficiently. So in this tutorial, we are going to experiment with two different methods of building that are available in FlexSim, 3D modeling and process flow modeling. So in the last stage of this tutorial, we will merge these two types of model together to make an even more powerful simulation model that combines the best aspects of both methods. So when we are finished with this tutorial, we are going to have a good general sense of how FlexSim works and the basic tasks involved in building a simulation model. When we are finished, our 3D model will look similar to the following image. So we can see there is an entrance from where the customers or the patients are coming in. They're waiting here and they're going to the service decks. Okay, and based on that, there's some happy customer, unhappy customers, and they're going to either the happy customer or the unhappy customer. And I can see that worker is also going back and forth between the back room and the service decks. So let's see. So the tasks that we are going to be covering in this tutorial, which is the basic FlexSim tutorial, we are going to build a 3D model. So in this task, which is 1.1, we are going to learn some of the basic about navigating inside of the FlexSim user interface while building 3D model. I think we have already done it, but we are going to do it in it again, okay? So because practice makes us perfect, right? Okay, so this task will give you some hands-on experience with the most important elements of the 3D model interface. In the second task, we will learn how to get data from our model using various simulation tools such as dashboard, chart, statistics collector. We will also learn how to analyze this data to learn how to improve our business systems efficiency. In the third task, we are going to learn how to build an identical simulation model to the 3D model you built in the first task, but this time we'll be using the process flow tool. So we will learn some of the basics about using the FlexSim process flow tool as we will build a process flow model. So link the model. In this task, we will learn how to connect the 3D model and the process flow model to control the overall logic. So we will also add an additional service desk to see if it improves our business system's overall performance. So yeah, that's a very good and a solid simulation model which will give us a strong foundational learning for FlexSim. So yeah, so in this video, we are going to cover 1.1, okay, which is building a 3D model using the 3D model method. So let's start. Okay, so let's see what it says. So one of the things that is unique, one of the things that make FlexSim unique is that it gives us the ability to create 3D representation of business system. While other simulation software can help you build theoretical model, FlexSim gives you the ability to view your business system in a more concrete way that is easier to understand and use. So I don't completely agree with this. There are other simulation software also that lets us visualize the system, namely AnyLogic, which is very good and very effective in the simulation world because we can do almost anything there. And the free version of AnyLogic lets us do almost anything if we are good at it. So as you can see in FlexSim, there is a limitation of 30 blocks. AnyLogic doesn't. AnyLogic has it, but that limitation doesn't actually impact us to create a very big model. Okay, so yeah, so in this tutorial, so let's resume. Okay, so in this tutorial task, we are going to learn some of the basic about navigating inside of the FlexSim user interface. While building 3D model, we will get some hands-on experience with the most important elements of the 3D model interface as shown in the image below. So this is what we did. We created a source block, we created a QE block, we created a process flow block, we created a sync block, and we connected a task executioner between here. Okay, so first thing it says that the first step in building a 3D model is to build the basic layout of the business system we are trying to simulate. So the customer service center that you are modeling has a service desk with one or more customer service representatives. So customers who arrive generally line up near the window until they can be helped by an employee. So in this simulation model, so this one is actually referring to not this one, but the one that we saw here. Okay, so the text there is actually referencing to this one. So let's see. So customers who arrive generally line up near the window until they can be helped by an employee. Okay. To simulate all these different elements, we will add object to the 3D model. Objects are the basic building blocks of a 3D simulation model. Different types of objects have different purposes and functions within the simulation model. We already know that. So some of the most common objects are flow item, which is the box or the sphere or the tote. Okay. So it says that objects that move or flow through the simulation model, usually from one station to another downstream station in the simulation model. The flow items will represent customer service center customers. Okay, so if we go back, you can see the customer is the flow item. Okay, so that's what it means. So the customer is the flow item, and the fixed resource, objects that remain stationary in the 3D model and interact with flow items. Each fixed resource performs a specific function. This simulation model will use a variety of fixed resources that will interact with the customers. And the tasks executed. Objects that can move around in the 3D model and perform tasks such as the transporting the flow item, operating machines, etc. For now, we won't use any task executors in our simulation model. We will add task executors later in this simulation. So uh, let's see the types of 3D object. And in this step, we will start by adding some fixed resources to our simulation model. So the first one is source, then QE, then processor, then sync, which is actually this one. We did it before, but let's do it again from the beginning. Okay, let's just create a new model. We don't need to save this. Okay, so let's create a new model with the default settings with second, meter, liter, start time, and date. Okay, okay, so it's telling us that create source block, create QE block, create processor block, create sync block. So let's create source. We are going to go under library to fix resources, go to source block, go to sync QE block, go to processor block, and a sync block. Okay, now that we have done it, source QE processor sync. Okay, so if needed, move the object so that we can approximately in the position shown in the previous image. Okay, so what it says that we can just click and drag and align them so that it looks tidy and good. Okay, so now that we have aligned our object, click the source to select it. Notice that the right pane changes to display the properties for this project. Under the properties heading, we will see a field where we can see the object's name. We can edit and type object names here. Go ahead and change the name from source 1 to customers arrive. So if I click here on source 1, you can see the properties pops up. So this properties was like the property of the environment, but if I click on the source, different properties for this element or this fixed resource pops up, and I can just change the name here, customers arrive or arrival. Okay, so I can see it has changed, the name has changed. So now repeat the previous step to rename all of the objects as below. So it wants me to change the name of the QE to waiting line, and it demands to change the name of the sync element. Okay, it wants me to change the name of the processor to service desk. Okay, processor to, and it requires me to create another sync element. So let's say I'm going to put it here. Okay, so now the sync by the processor is the happy customer. Okay, so here is one sync, and another sync is going to be by the waiting line. So let's just do that. So this sync is going to be by the service desk, and it's going to be for the happy customers, and this sync which is going to be by the waiting line is going to be for unhappy customers. Okay, so now that we have renamed it, it tells us to connect the 3D object. Okay, so in this step we will connect the 3D object so that customers move from one object to the next in the appropriate order. In other words, we will create a logic that will help items flow from one fixed resource to another. There are several different methods for doing this in FlexSim. In this step, we will learn how to connect objects using the port connections because it is the easiest and the most straightforward method. So in FlexSim, a port is a point on an object where carry flow items can be transferred from one object to another. A port connection is a connection between ports on different objects. Ports create relationships between objects and that allow them to communicate with each other and exchange flow items. So the connection port is the port connection, okay? So it tells us to connect it. So here you can see it's connecting it. It's connecting the customer's arrival with the waiting line, the service text with the happy customers. Okay, so now let's see what it says. Click the connect object button on the toolbar to open a menu. Select connect object to enter connection mode. When you are in connection mode, your mouse pointer will change to plus sign with chain link symbol. So once you're in connection mode, you can connect two objects together. Click the customers arrive object and click the waiting line. You will see that it creates a connection port. Okay, so let's say this is something new because tells us to click on the connect objects on the toolbar. So let's see, where is this on the toolbar? Connect objects, where is that? Here on the toolbar. We can just click the shortcut. You can just click here, or you can just press the letter A on your keyboard and hold it, and you can see it has changed. Or you can just click here and you can see I can just click here and I can just click here, and it created a connection, and I'm going to press escape to get out of this connection. Okay, so now you will still be in connection mode after connecting these two objects. If you wanted to connect another object to the QE, you would stay in connection mode. But since you are done connecting to the QE to object, simply press the escape key to exit the connection mode. So you will turn on connection mode once more time, but this time we will use a shortcut. Press and hold the A key, then click the service desk, and then click the happy customers. Okay, so let's see. See, if I hold it, yeah, it does the same thing. If I just hold it, I click on the service text, I click on the happy customers and I can just release the A, okay, to get out of the system. So yeah, so this is very handy and very effective. So when we're finished, our 3D model should look similar to the following image. Yeah, this is what it's looking for. So now let's say it's telling us to run the model for the first time. In this system or this step, we will run this model at this point to see what happens when we run the model. For now, we will just run the model for the first time, but a later step in this tutorial will explain why and how to run a model in more depth to run the model. So press the reset button on the simulation control bar, which is just beneath the main toolbar. Pressing reset clears the simulation model and returns to its steering values. Okay, so let's go back to the software. Let's click on the reset and then let's click on the run. Let's see what happens. Okay, I can see the flow item, which is the box, is piling up on the QE, which is the waiting line. Okay, because we haven't still connected the waiting line with the service desk, it's not going to flowing out. It's not going to flow out. Instead, it's going to wait or gather or store itself in a waiting line. Okay, I can see. So this looks good actually. You can see the items just stacks one upon the another. Okay, let's see what's next. So it tells us to stop the simulation. At this point, we will see the source create flow item and place them at the waiting line. Since we haven't created any logic that will move this flow item, they will simply stack up inside the QE until you stop the simulation. So we have to go back and stop the simulation, otherwise the items are just going to keep on stocking. So I clicked on stop. Okay, so now they are telling us to create a list to track customer. This is something new, okay? I haven't told you anything like this before. So in the previous step, we learned how to connect the flow of object using port connection. In this step, we will learn how to use a tool called global list to create more complex flows between fixed resources. So in this model, the flow items will represent customers. Okay, now right now it was box. So now it tells us it's going to change itself, change the flow items to the customer. When customers enter the waiting line, they will be added to a list of waiting customer, which will track how long customers have been waiting. The service desk will help the customers who have been waiting the longest first. Okay, fine, that's good. However, customers who have waited more than 200 seconds will get frustrated and leave through the unhappy customer sink. So to create this functionality, we will use a global list which can filter and prioritize flow item using the sophisticated sets of criteria for more. Okay, so in this step, we will set up a flow item list and name it waiting customer. So we will create this list using the toolbox, which is the place where you can access nearly every tool in FlexSim. So when you create a list, we will first need to set up this field. Field determines which information the list will track. By default, the item list comes with 4 default fields, each with pre-programmed logic. These fields are merely suggestions for what kind of field you might want on a flow item list. You can delete this field or add other pre-programmed or custom fields as needed. So let's see, where is this list actually? It says the list is on the toolbar. Disconnect new selection, create objects, tree, script. I can't see it on the tools. No, it's not there. Okay, okay. So one of the default field is the age field, which tracks the amount of time that has elapsed since the flow item was created by the source. While this field would probably work for this list logical need, it might be better to add an age in QE field for more accuracy. The age in QE field tracks the length of time the item has been on the list. And okay, in other words, it will track the length of time that has passed since the customer joined the customer waiting line. So we will add this field in this step. To create a global list, look in the left pane where the library is located, near the top of this pane, you will see a tab called Toolbox. Click this tab to open the toolbox. In the toolbox, click Add button to open a menu. Point to Global List. It does tell us to go to Toolbox, and it tells us to click on this plus icon, and there are many things here actually. Agent system, color palette, connectivity, dashboard, down behavior, flow item, global list, and many other things. So right now we need to click on the global list. So let's see what additional. Okay, point to global list and then select item list. Okay, so we need to create an item list from here. Okay, so now we have created an item list. So there are some parameters as it mentioned. It has a type of label. It it is automatically calculating or storing the time, which is called age. So this is just doing when the that material is or that flow item is created until the current time. Okay, so it's just storing that time, that amount of time, the distance. It's this straight line distance from item to puller. Okay, fine. The QE size. Okay, fine. So in the top box, change the name of the list to waiting customers. Okay, so this is called item list 1. We are going to change it the name to waiting customers. Okay, now we have changed it to waiting customers. With the fields tab open, click the add button to open a menu. Select agent QE, and the new field will show up at the bottom of the field. Okay, so this is my field tab. It's telling us to click here and click on the age in QE. Okay, so it has created a new block, new parameter or variable, which is going to be dynamic. I can see here. So, okay, by dynamic, what it means that as the simulation is progressing, this is going to update itself. Okay, we don't need to write some code to update it manually. So press the delete button next to all the other fields to remove them, to remove since they are unnecessary. So it's telling us we don't need this. Okay. Let's say we don't need the age, we don't need the distance, we don't need the QE size, we just need the age and QE. Okay, so now it's also telling us to delete the label field. We also don't need it. So now you will change the name of the agent QE to something more descriptive. Click the expression field box, delete the current text and change its name to wait time. Wait time. Okay, we did that. Now in the back order, check the reevaluate all values on push checkbox. So what does this do? This checkbox will ensure that the list entries are updated every time a new customer joins the updating waiting line. We will need this functionality to update the wait time for customers who are already on the list. Okay, so we are going to go to the back order. We are going to click on reevaluate. Okay, so we have clicked on reevaluate all values on the push list. Okay, so this will update the list whenever a new customer or a new flow item enters. Okay, so you need to click on the press OK, and your new waiting customer list should now appear under the global list group in the toolbox. So let's click on OK. Yeah, it's appearing here. Okay, under global list the waiting customers is here. So that was the step 4. Okay, so we learned something new, which is the global list. So now it's telling us to edit the model's logic. Okay, in this step we will edit the properties of the 3D object to create the basic logic of the simulation model. So the following is an explanation of the objects we will edit and reasons why we will make these changes. So the customer's arrival source. So let's see what it says. So most 3D models begin with a source object that creates the flow item that will move through the 3D model and interact with object. In this model, the flow items will represent customers coming to the customer service center. So the source will determine how frequently customers arrive. We already know that. For this model, excuse me. So for this model, we will change the arrival rate for customers so that the customer arrives approximately every minute. We use a statistical distribution called exponential distribution to randomly calculate the arrival rate within a range of times averaging around 60 seconds. So by default, the source creates flow items that looks like boxes. Since the flow items in the model represent customers, you will change the flow item class so that it looks like a person. So we have done that before. So yeah, we are going to do that. So let's see. It's telling us to click on the customer's arrive source to open its properties on the right. On the source section, click the flow item class and select man. Check the arrival at time 0 box so that the customer arrives right when the model begins. Note that the inter-arrival time is set to use exponential statistical distribution with customers arriving randomly, averaging around 10 seconds. Click the Edit Properties button to open the distribution chooser and edit the properties for this distribution. In the scale box, change the number to 60. Okay, so that's a lot of thing. So first thing, we need to click on the source customer arrival box and in the flow item class, which is telling us, okay, flow item class and select man. Okay, so from box, you have to change it to man. And for arrival style, inter-arrival time, you have to click on the arrival at time 0 to ensure that when the simulation begins, the box arrives instantly. And in the inter-arrival time, it told us to click on something, statistical distribution, a lot of things. Okay, let's check that again. Check the okay. Notice that the inter-arrival time is already set to use the exponential statistical distribution with customers arriving randomly. Click the Edit Properties button. Okay, this icon. Okay, so it's already using the statistical distribution. So you can just click here, Edit Parameters for this option, and it will open this block. So in the scale, we are going to change it to 60. So it means that from between 0 and 60 second, every one customer is going to arrive. Okay, because this is in second. If you want to change it to any other time unit, you can do it from here. Okay, so there goes that one. Now it tells us to click the waiting line. Let's see. So in the waiting line QE, you will set this up object so that the customer's flow items are added to the waiting customers list as soon as they enter the waiting line. You will also change the QE so that customers form a line rather than getting stacked up inside the QE. Okay, that's it. Very important. Okay, so first thing, click on the waiting line. Next thing, under the QE section, click the item placement menu and select horizontal line. Okay, first thing, let's click on the waiting line. In the once I click on it under properties here under the QEs, there is a capacity of 1000. So this is the maximum capacity of flow items it can hold. So right now it's 1000. So item placement, I want it to stock like weight in a horizontal line. Okay, I don't want them to pile up like the boxes because we are using customers right now. Under the output section, click the arrow next to the send to port box to open a menu. Point to use list, then select push to item list. A box will appear to select the appropriate item list. Confirm that the waiting customers has been selected. Okay. Under the output section, click the arrow next to the send to port box to open a menu. Point to use list and then select push to item list. Under the output, uh, under the output, under the output section, click the arrow next to send to port box to open a menu. There are many things, expression, QE size, random, use list, and other use list. So what I did here, under send to port, I clicked here. This menu popped up. I'm going to use a list and I'm going to push to item list. So another option was here, pull from fixed resource list. So we're not going to be using that now. It's telling us to use the push to item list. Okay. So once I click on that in the list, I can see there is just waiting customer and it's already there. So I don't need to add it. But if it's not there, you can just select here and click on this to select that list. So if you remember, the waiting customer list is the list we just created, okay, from the toolbox. Okay, so click the service desk processor to open its properties on the right. Let's see what we need to do in the service desk. So in the service desk, this object represents the time it takes an employee to help a customer. For that reason, we will set up this object so that it pulls the first customer from the waiting customer list and when it is ready to help another customer. Okay, so you set up this object so that it pulls the first customer from the waiting customer list. Okay, we will also set the amount of time it takes an employee to help a customer. We will use the log normal to statistical distribution so that it will take approximately 92 seconds to help a customer. Okay, so first thing, let's click on the service desk. It will open up the properties on the right. On the processor section, click the animate items checkbox. On the processor, okay, let's click on the service desk. On the right side, the properties are popped up and click the arrow next to the process time, not this one. Under the processor section, clear the animate items checkbox. Okay, under the processor section, okay, right here. Okay, here is an animate. Okay, I don't want it. I'm going to uncheck it. Um, then click the arrow next to the process time box to open a menu. Point to statistical distribution and select log normal 2. So if I come here, process time, I'm going to I'm going to click here and select statistical distribution and I'm going to use the log normal 2 and the values are going to be, location is going to be 90, 3.1, 0.5, 90, 3.1, 0.5. Let's open it again. Okay, let's edit it. 90, 3.1 and 0.5. Okay, let me see if that's okay. 3.1, 0.5. Okay, that's good. Now, next thing it tells us, okay, notice in the chart that most customers will take approximately 91.5 minutes. Okay, this is the most one to 93.5 minutes. Okay, so this most of the customers is here, but some might take a little more longer or less. So it's just distributing the time it takes to process the customers. So under the input section, check the pull checkbox. So under the input section, so this was the output, this is the input. So I'm going to click on the pull. So pull strategy, pull requirement. So it tells us that under the click the arrow next to pull strategy box to open a menu. Pull strategy. Okay. Open a menu. Use list. Pull from item list. Okay. So it's going to use the waiting customers and then select the pull from item list. Confirm that the waiting customer list has been selected. Okay. Next to the query box, click the add button to open a menu. Next to the query box. Next to the query box. Mm, Next to the confirm. Okay. Next to the query box, click the add button to open a menu. Let's see. I don't see it. Where is that? I have the labels here. I have the processor, output, pull. Mm, Where is that? Next to the query box, add button to open a menu, point to order by and select wait time. Next to the query box. Mhm. Okay, let's go there back again. Okay, here is the query blocks. Okay, we need to click on the plus order by wait time. Okay, it says ascending. So let's see what it says here. Edit the query to change the ascending to descending since you want to pull the customers that has the longest waiting time. So here ASC is for ascending and DESC is for descending, I guess. Let's see. DESC. Okay. So we are using the descending because we want the customers first with the longest waiting time. Okay. So now edit the query to change the to descending. Click the unhappy customer sync to open its properties on the right. Okay, now let's see why we need to click on unhappy customers. So sync removes flow items from the model. We will set this sync up so that it will search the waiting customer list for any customers that have been waiting longer than 200 seconds. Okay, it will pull any customers who meets this criteria and remove them from the model, representing customer getting frustrated and leaving. Okay, so it's telling us to click on the unhappy sync and click on the input section and check the pull checkbox. Unhappy customers under the input pull. Okay, so under pull, click the arrow next to the pull strategy to open a menu, point to use list, then select pull from item list. So similarly, use list, pull from list, waiting customers. Okay, so now we need to do confirm that waiting customer list has been selected. Next to the query box, click the add button to open a menu, point to where and select wait time. Query where wait time. Wait time is going to be greater than 200. Greater than 200. So any customers who are waiting there for more than 200 seconds is going to be pulled by this unhappy customers block. Okay. So now that we are done editing the 3D object properties, consider saving your model. Okay, so we are almost there. So it tells us to save the model. So we're going to go to File. We are going to click on Save As, and I'm going to name this, and I want to keep it somewhere. Let's say FlexSim Basic Model V1. Okay, so I've saved it, and it's saving, I guess. Yeah. Okay, so I've saved it successfully. So the step 6 is to run and test the simulation model. So this is the last step for this tutorial. I mean, for the basic tutorial. Okay, we'll be covering more tutorials ahead. So in this step, we will run your simulation model again. Running a simulation model is an important step in simulation model building process. In the early phases of model building, it helps you to test and troubleshoot your model to ensure that you've built it correctly. See, running a simulation model, uh, you can find more information here. To run the model, click on reset, click on run, and stop button to stop it. So here is the reset, run, stop, fast forward, skip, step. When you first run the model, a customer will immediately appear in the service desk. Gradually, more customers will appear and form a line in the waiting line. Okay, let's see. So I can see there is a customer there. Now I'm going to click on the stop. So I don't see a customer in the service desk. So did I leave anything out? Hmm. Okay, now I can see. Okay, so it told us to animate, to check out the animate, but that's not it. We have actually have to animate it, otherwise the people is not going to be visible. Okay, so this has to be here. You have to check it, not clear it. So that was something wrong there. Okay, so now, okay, I think these are happy customers. Yeah. Okay, I get it. Now let's pause it. Click on stop. Okay. So if your simulation model isn't behaving in a similar manner, or if you're getting error messages, double check what you have followed all the previous steps correctly. In our case, there is no error. So also right now the 3D visual probably took a little strange and unnatural. Be aware that in the early model building phase, you are more concerned about building on the basic model and making sure it works correctly than making it look realistic. In future tutorial tasks, you will learn how to improve the visuals of a 3D model to make it look more natural. As we are going to work on the next step in the tutorial, it might be more helpful to run the simulation model at a faster speed than the default speed. It might be also be helpful to run the simulation model for a full day to get representative data from the model. Since a typical day in the simulation customer service center lasts 12 hours, we will set the simulation to run for 43,200 seconds, which is equivalent to 12 hours. So to change the speed and stop time of the simulation run, click the arrow next to runtime box on the simulation control bar to open a menu right here. So if we just click here, it will open a menu and we can display mode, start time, stop time. Okay. So this is the time it's starting and let's see what it tells us. Okay. So if we just click here, we can start the stop time and we are going to run it for 43,200 seconds. We are going to run it for 43,200 seconds, okay, which is equivalent to 12 hours. Click the arrow next to run speed box on the simulation control bar. In the custom box, type 1000 and click the set button. So this is going to set the speed of the simulation. So here you can also use this slider to take a value, or you can just click here and you can set 1000. Try running the model a second time to see how it affects the simulation run. Okay, now I can see it's going a little fast. Okay, so by unnatural 3D views, it meant that we cannot actually see the people coming to the unhappy customers. We cannot see the people going to the happy customers. Okay, so this is the limitation right now. But as we are moving forward into the next lecture, we will be improving it, and hopefully, we are going to learn something valuable. So I'm requesting you to like and subscribe to my channel again. And if you have any questions or if you have any feedback, you can just comment below and have a good day and keep on learning. Okay, so best of luck.